Dear students, today we will discuss about the multivibrators of analog electronics. So, what is the multivibrators and what is the application and what is the working principle of multivibrators? So, multivibrator is an electronic circuit used to implement a variety of simple two-state systems such as oscillators, timers, and flip-flops. So that is the multivibrator, and it is characterized by two amplifying devices, transistor, electron tubes, and other devices also. So cross coupled by resistor and capacitors, it has two states, low state and high state, or 0 and 1. 0 for low state and high for 1 for high state. So that is the circuit diagram of the multivibrators, in which we have two NAND gates here, and the connection of the two NAND gates as in given circuit diagram as shown in figure also. So there are three types of multivibrator circuits. First one is I-stable multivibrator, second one is the Y-stable multivibrator, and third one is the mono-stable multivibrator. So there are three types of multivibrator circuits. So in A-stable, in which the circuit is not stable in either state and it continuously oscillates from one state to another state. So that is the ice stable. There is no stable state and they continuously oscillate from one state to another state. Due to this, it does not require an input, clock pulse or other. So in the ice stable, there is no requirement of the inputs or clock pulse or other types inputs. So I-stable multivibrators are a type of free running oscillators, that is the free running, that have no permanent meta or steady state, but are continually changing their output from one state or low to the other state high and then back again to its original states. This continual switching action from high to low and low to high produce a continuous square wave output. Those timing cycle is determined by the time constant of the resistor, capacitor, RC network connected to it. So this is the diagram of the high-stable multivibrator with the help of NAND gate. Using NAND gate here. So in this high-stable multivibrator, the output is the square wave at the Q point, that is the output point. So output of this high-stable multivibrator will be square wave. And what is the application of R-stable multivibrators? So R-stable multivibrators are used in amateur radio equipment to receive and transmit radio signals. R-stable multivibrators are also used in Morse code generators, timers, and systems that require a square wave, including television broadcast and analog circuits. So these are the some application of bistable multivibrator, and there are some advantage of stable multivibrator. So this multivibrator continuously switch between one state and another. This allow and perform work at consistent rate without influence from any outside force or events. Additionally, high-stable multivibrators are inexpensive to produce, are relatively simple in design, and can remain functional for extraordinary amounts of time. So these are the some advantage of the high-stable multivibrators. And we have also some disadvantage of high-stable multivibrators. So high-stable multivibrators do not transfer the entire output signal to the input. This is due to resistance within the circuit, lack of completely closed loop at the output terminals, and the tendency for one capacitor or transistor to observe energy at a slightly different rate than the other. Although the amplifier restores the lost energy when it amplifies the signals, the signal will eventually be too small to be any use. So these are the some disadvantage of the high stable multivibrator. Next one is the multivibrator is bistable multivibrator. So in this multivibrator circuit, both states are stable and the circuit will remain in either state indefinitely. Indefinitely. This type of multivibrator circuit passes from one state to other only when a suitable external trigger pulse T is applied, and to go through a full set reset cycle, two triggering pulses are required. So this type of circuit is also known as bistable latch, toggle latch, or simply T-latch flip-flop. Such a circuit is important as the fundamental building block of register or memory device. So then the bistable latch or toggle latch is a two-state device in which both state either positive or negative or logic 1 or logic 0 are stable. So this is the circuit diagram of the bistable multivibrator, and in this circuit diagram the circuit designed with the help of NAND gate, and here input is applied by the trigger input and in the form of set reset, and also output measure across the output terminal of this bistable multivibrator. That is the square wave in the shape. So what is the application of bistable multivibrator? So bistable multivibrator have many applications such as frequency dividers, counters, or as storage device in computer memory. What they are best used in circuits such as latch and counter. So mainly used bistable multivibrators in latch and counters. Next multivibrator is the third type, that is the monostable multivibrator. So in monostable multivibrator has only one stable state and is trigger externally with it returning back to its first stable state. So monostable multivibrator or one shoot pulse generators are used to generate a single output pulse, either, either high or low, when a suitable external trigger signal or pulse T is applied. So time constant for this T is equal to 0.8 RC plus trigger in seconds. So this is the circuit diagram of monostable multivibrator by using of the NAND gates. And applications of monostable multivibrators. So monostable multivibrators are used in a number of applications and can be found wherever a square wave or time interval is necessary for the success of system. For example, monostable multivibrators were once used in analog system to control and output signals, frequency, synchronize the line and frame rate of television broadcast, and even moderate the tunes of different octaves with electronic organs. So additionally, before the integrated circuit invention, monostable multivibrators were connected together in a series to divide frequencies. So these are the some applications. And what is the advantage of monostable multivibrators? So monostable multivibrators generates output signals at time intervals in the form of square wave, and they are have the size of stable multivibrators and can therefore be used in more diverse situations. Monostable multivibrators can be connected to one another to provide additional functionality. They are relatively simple in design and are inexpensive when compared with other type of oscillators. And there are some also disadvantages of monostable multivibrator. So one main disadvantage of monostable multivibrator is that the time between the application of the next trigger pulse T has to be greater than the RC time constant of the circuit. So this is the one main disadvantage of the monostable multivibrator. Next topic is the comparator and Smith triggers. So in comparator circuit, find frequent application in measurement and instrumentation systems and learning objects. Understand the op-amp comparator with and without an offset and its use. So understand the Smith trigger and its benefits in noise rejection and improve switching speed. So one is the op-amp comparator, operational amplifier comparator. So this is the circuit diagram of op-amp comparator, in which there are two input terminals. One is inverting terminal and second is non-inverting terminals. And the voltage between these two terminals is the voltage difference, input voltage. And the prototype of op-amp switching circuit is the op-amp comparator. This circuit does not improve feedback in this circuit. So here the output voltage of this op-amp comparator will be A into V minus V1 minus V2, where A is the gain of the op-amp and V1 is the non-inverting voltage and V2 is the inverting voltage. So output voltage of the op-amp comparator V out equal to A into V1 minus V2. Because of the large gain that characterized open loop performance of the op-amp, here gain is very large and A greater than 10 to the power 5. Any small difference between the input voltage will cause large outputs. The op-amp will go into saturation at either extreme according the voltage supply value and the polarity of the voltage difference. One can take advantage of this property to generate switching waveforms. So consider the following non-inverting op-amp comparator. So this circuit diagram shows the non-inverting op-amp comparator, and in which the input voltage applied to the non-inverting terminal of the op-amp. So this name is non-inverting op-amp comparators. The comparator is perhaps the simplest form of an analog to digital converters. Or for example, a circuit that converts a continuous waveform to a discrete value. The comparator output consists of only two discrete levels, 0 and 1 or low and high. So input and output of non-inverting comparator. So these two waveforms are given in this waveform. One is the output voltage and one is the input voltage of the comparator. So it is possible to constant and inverting comparator connecting the non-inverting terminal to ground and connecting the input to the inverting terminals. So here the waveforms of input and output of inverter comparator. The output is the square waveform and input is the sinusoidal waveform. Next, comparator with offset. So a simple modification of the comparator circuit consists of connecting a fixed reference voltage to one of the input terminal as shown in this figure. There is input supply voltage given to the non-inverting terminal and second reference voltage applied to the inverting terminal of this circuit diagram. So the effect of the reference voltage is to raise or lower the voltage level at which the comparator will switch from one extreme to the other. So below is the waveform of a comparator with a reference voltage of 0.6 volt and an input voltage of sine omega t. So in these input and output waveforms and also reference voltage, note that the comparator output is no longer a symmetric square wave. And another useful interpretation of op-amp consider its input-output transfer characteristics. So in non-inverting zero reference, no offset comparator often called a zero crossing comparators. So here shown below is the transfer characteristics for a comparator of the inverting type with a non-zero reference volt. So that is the transfer characteristics given in second waveform diagram. And very often in converting an analog signal to a binary representation, one would like to use voltage levels other than plus, minus, B saturate. Commonly used voltage levels in this type of switching circuit are 0 and 5 volt. So special purpose integrated circuit package are available that are specially designed to serve as comparators. These typically can accept relatively large inputs and have provision for selecting the desired reference voltage levels. So, for an example is an LM311 which provide an open collector output. The open collector output allows the user to connect the output transistor to any supply voltage of choice by means of an external pull-up resistor, thus completing the output circuit. So the actual value of the resistor is not critical since the transistor is operated in the saturation mode, and value between a few hundred and a few thousand ohms are typical. So next device is the ISMA trigger. This is also a square wave generators. So in ISMA trigger, one of the typical application of op-amp operational amplifier comparator is in detecting when an input voltage exceeds a present threshold voltage. The desired threshold is then represented by a DC reference, V reference connected to the non-inverting input, and the input voltage source is connected to the inverting input. So the presence of noise and a finite slew rate of practical op-amps require special attention. So two improvements are discussed. First, how to improve the switching speed of the comparator, and second, how to design a circuit that can operate correctly even in the presence of noisy signals. Comparator responds to noise inputs. So first diagram or waveform diagram show the noisy input waveform, and second waveform diagram show the comparator output waveform, that is the shape of square. So one very effective way of improving the performance of the comparator is by introducing positive feedback. Positive feedback can increase the switching speed of the comparator and provide noise immunity at the same time. So here the transfer characteristics of the smart trigger. So that is the output in the shape of square, and also here the circuit diagram of the smart trigger in which feedback is used by the R1 resistance, and there is the voltage input applied to the inverting terminal, and feedback network is across the non-inverting terminal of this operational amplifiers. So that is the circuit diagram of the Smith trigger, and also first waveform diagram show the transfer characteristics of the Smith triggers, in which the output voltage between minus R2 upon R1 plus R2 into B set to R2 upon R1 plus R2 B set. So if it is desired to switch about a voltage other than zero, a reference voltage can also be connected to the non-inverting terminal. So switching level for a Smith triggers. So V input is greater than R2 upon R1 plus R2 B set plus B reference into R1 upon R1 plus R2. So positive going transition, that is the positive going transition voltage. Next one is the negative going transition. So V input is less than minus R2 upon R1 plus R2 B set plus B reference R1 upon R2 plus R1. So this is the positive going transition voltage and negative going transition input voltage for the switching level of the Smith triggers. In effect, the Smith trigger provide a noise rejection range equal to plus minus B set into R2 upon R1 plus R2, within which the comparator cannot switch. Thus, if the noise amplitude is contained within this range, the Smith trigger will prevent multiple triggering. So that is the reference books for this topic, electronics device and circuit by the Millman and Alkias. There are some multi-choice questions, and we will discuss one by one questions. So first questions, a one suit is a type of option A, high stable multivibrator, monostable multivibrator, option C, timer, option D, B and C are correct. So one suit is a type of multivibrator is the monostable and timer. So here correct answer option D. In next questions, high stable multivibrator is in both of the state. First a stable, stable, second unstable, and next free running, and last all are correct. So stable multivibrator is the unstable in both of the state or low state or high state. So stable multivibrator is the unstable in the both state. So correct answer is option B. Next, A dot dot is a pulse generator circuit. So option A multivibrator, option B frequency generator, option C amplifier, and option D rectifiers. So here correct answer is option A. A multivibrator is a pulse generator circuit. That is, multivibrator is the pulse generator circuit and generate the pulse and as well as a square wave generator circuit. So correct answer is option A, multivibrator. In next questions, multivibrator can be used as an electronic delay line Option A, monostable. Option B, high-stable. Option C, bistable. Option D, all are correct. So here correct answer is option A, monostable. So monostable multivibrator can be used in electronic delay line. So this is the application of monostable multivibrator as a electronic delay lines. And next questions, a leading edge trigger multivibrator may be used as pulse shaper. So option A, bistable. Option B, high-stable. Option C, monostable. Option D, none is correct. So here correct answer is monostable, because in monostable a leading edge trigger multivibrator may be used as a pulse shapers. So that is the monostable. In next questions, a trailing edge trigger monostable multivibrator may be used as a trailing edge trigger monostable multivibrator used as option A, pulse reshaper. Option B, pulse delay. Option C, pulse shifter. Option D, all are correct. So here correct option is answer B, pulse delay. So a trailing a trigger monostable multivibrator may be used as a pulse delay. In next questions, a trailing edge trigger monostable multivibrator may be used as pulse reshaper, pulse delay, pulse shifter, all are correct. So correct answer is pulse delay. And next question, a monostable multivibrator is frequently used for option A as a memory, option B timing circuit, option C distorted device waves, and option D is A and B are correct. So here correct option is B, because a monostable multivibrator is frequently used for memory and as well as timing circuit. So correct answer is option B. The triple 5 IC timer has option A, 3 comparators. Option B, 2 comparators. Option C, 1 comparators. Option D, 4 comparators. So IC, triple IC is the used as a timer, and it have the 2 comparators. So here correct option is the answer B, triple 5 timer IC have the 2 comparators. So thank you.